So in this lesson, we are going to look at indices and the rules of indices. Now, if you have a look on your log tables, so on page 21, but it'll be marked as indices. Okay, so it'll be like this in your log tables. This is what you'll come across. So these rules, you don't need to memorize the rules, but you do need to understand how they work. And that's what we're going to talk about now, and we're going to work through each of these rules and work through some examples. So what we want to kind of think about before we start getting into indices, we want to kind of start to get an idea of what indices are all about. So the first thing we'd say is that if we take the numbers, let's say, so 1, 2, 3, 4, 5. Okay, so these are what are called counting numbers or natural numbers. And they're useful. Why are they useful? Because they allow us to count things. So for example, if I wanted to count the number of letters in the word indices, I can use natural numbers. I can say 1, 2, 3, 4, 5, 6, 7. Okay, so we use these natural numbers to count things, to keep a count on things. Then if we take, let's say if we take something like this. So if we have, let's say, so 5 plus 5 plus 5 plus 5 plus 5. Okay, so instead of writing something out like that, okay, which is, it's quite long, maths is always about shortening things. So what we can do is we can write this as a multiplication. So we can say, for example, 5 multiplied by 1, 2, 3, 4, 5. So it's 5 multiplied by 5. Okay, and these two things mean the same. Okay, so 5 and 5 is 10, and 5 is 15, and 5 is 20, and 5 is 25. But instead of writing it out like that and taking up loads of space, we can just as easily write it like this. So 5 multiplied by 5. So multiplication, if you like, is a way at shortening addition. Okay, so instead of having a big long addition like this, we can just write something short and nice like this. Now, what if we have something like this? So what if we have, let's say, so instead of adding 5 together, we have 5 multiplied by 5, multiplied by 5, multiplied by 5. Okay, so again, this is big and long. We don't really like that. We want to write this in short notation. So what we can do is we can use what are called indices. So this number here, I can write it like this. So I can say 5 to the power of, okay, so we count the number of 5s that we have. So 1, 2, 3, 4. So it's 5 to the power of 4. And this here is what's known as the indice. And this here is what's known as the base number. So instead of writing out multiplication like this, we can just shorten it down to something like this. So 5 to the power of 4. So what you can say then is that indices is to multiplication what multiplication is to addition. So for example, we can use multiplication here to shorten this addition. Okay, so and then we can use this indice here to shorten this multiplication. So that's essentially like what indices are. So we're talking about, a number which is the base number. So this is the base number. And then this here is the indice. Okay, and sometimes it's called a power. And this is what we're talking about. So in maths, you're going to come across problems that have powers in them. So there's a number of rules that we can use in order to make our life a little bit easier when it comes to working with indices. And that's what we're going to look at now. So we have these rules here. And what we're going to do now is we're going to look at some of these rules. So the first rule is this one here. Okay, so this is the multiplication rule. So it's the multiplication rule. And basically what this says is, so it's a to the power of p multiplied by a to the power of q is just equal to a to the power of p plus q. So what does that mean, or what would that look like? So it looks like something like this. So if I have, let's say, so 4 to the power of 2 multiplied by 4 to the power of 3. So notice that we have the base numbers in these two are the same. So that's the same as saying, so when we take this rule here, so we have, this is a to the power of p multiplied by a to the power of q is equal to a to the power of p plus q. So basically all we have to do is with these two, we keep the base number, so it's going to be equal to 4 to the power of 2 plus 3. So we just add the two of these together, so it's 2 plus 3. And that's going to be equal to 4 to the power of 5. And that's what comes from this rule here, okay? So if you like, the a is just the number, okay? So it's represented by a in the formula. The p in this case is this number here, so the first number, and the q is just this number here. So basically all it means is that if you have two indices that have the same base number and you multiply them by each other, all you have to do is just add the indexes together at the top. So you're just basically adding these guys together up here at the top. So just adding these two together. So that's all that means. So as another example, let's say if we have, let's say, 3 to the power of 2 multiplied by 3 to the power of 6, okay, what we can do is we can just add these together. So it's going to be equal to 3 to the power of 2 plus 6, which is equal to 8. Okay, so and that's that. That's basically all it is. And if you think about it, it makes complete sense. So if we take this one here and if we write this out, so what's 4 to the power of 2? So 4 to the power of 2 is just going to be 4 multiplied by 4. Okay, so that's 4 to the power of 2. And then 4 to the power of 3, so it's going to be multiplied by 4 to the power of 3 is just going to be 4 multiplied by 4 multiplied by 4. So then if we just take away the brackets, it's 4 by 4 by 4 by 4 by 4, which is equal to 4 to the power of 5, because there's 5. 1, 2, 3, 4, 5. So that's the first rule. So when you're multiplying indices that have the same base number, you just add the powers, or you add the indices together, and that's it. And that's what this rule is about here. That's what it's represented by. So the next rule then is division. Okay, so this is the rule for division here. So if we take division, and I'll just highlight this one for us here. So this rule basically says that a to the power of p divided by a to the power of q is just equal to a to the power of p minus q. Okay, so what would that look like? So if we had something like this. So imagine we had, let's say, 4 to the power of 6, and we are dividing that by 4 to the power of 2. Okay, what that's going to be equal to is 6 minus 2, which is going to be equal to 4 to the power of 4. Okay, so that's what it means, and that's what this rule means. So when you're dividing two indices that have the same base number, now remember they have to have the same base number in order for this rule to apply. All we do is we take the power and we subtract the top one from the bottom one. And this is what it looks like. And this makes sense. So if we write this out, so what's 4 to the power of 6? So that basically means 4 multiplied by 4 multiplied by 4 multiplied by 4. So 1, 2, 3, 4, 5, 6. Okay, that's what 4 to the power of 6 means. And we're dividing it by 4 to the power of 2, which is just 4 multiplied by 4. And then if we cancel these out, so for example, 4 will cancel out with 4, this 4 will cancel out with this 4, then we're just left with, so 1, 2, 3, 4, which is going to be equal to 4 to the power of 4. Okay, so that's that one. So basically the second rule then is for division. So when we are dividing two indices by each other, we take the index or the power of the top indice and we subtract it from the bottom indice. So in this case it's 4 to the power of 6 divided by 4 to the power of 2. That's just going to be equal to 4 to the power of 4. So it's just 6 minus 2. Okay, so that's the second rule, and this is how it appears, for example, in the logbook. So the next rule then is a power to a power. So let's have a look at this. So let me just move this down here. So a power of a power, and that is this rule here. Okay, so this is how it shows up in your index or your log tables. So a to the power of q to the power of q is going to be equal to a to the power of p multiplied by q. Okay, so let's think about an example of that. So if I have something like this, so imagine I have, let's say, 3 to the power of 3, and then that's all raised to the power of 2. Okay, so it looks something like that. So basically what we do with this is we just multiply the indices by each other and keep the base number. So that's going to be equal to 3 to the power of 6. So it's just 3 multiplied by 2. And this makes sense. So why is this the case? Like, why is it like that? Because, so what is 3 to the power of 3 to the power of 2? Well, if we take, so what's 3 to the power of 3 first of all? So 3 to the power of 3 is just 3 multiplied by 3 multiplied by 3. So that's 3 to the power of 3. And then if we take this then and multiply 3 to the power of 3 to the power of 2, that means this. So essentially means this multiplied by itself. So it's going to be multiplied by this again. So 3 to the power of, 3 multiplied by 3 multiplied by 3. And then if we look at all of this then, so it's 3 by 3 by 3 by 3 by 3 by 3. So that's 1, 2, 3, 4, 5, 6. That's equal to 3 to the power of 6. So 3 to the power of 6. So that's the rule. So that's the third rule. So for example, when you have a power raised to another power, and what you have to do is you just multiply the indices, the indice on the inside by the indice on the outside, just like this example here. So 3 to the power of 3 to the power of 2 is just going to be equal to 3 to the power of 6. So you just multiply these two numbers here by each other. So that's the third rule. So a power raised to the power. So the next rule then is this rule here. So it's the fourth rule, or the power of 0. So again, if we have a look at this example here, so this one here, let me just change the color. So if we do blue, so this guy here. So what we have here is a to the power of 0 is equal to 1. So basically what that means is that any number that's raised to the power of 0 is always equal to 1. So as an example, if I have 5 to the power of 0, that's just equal to 1. If I have even like, let's say 3 to the power of 0, that's equal to 1. So that's the fourth rule there. Okay, so this is the first rule. So this is the first rule, the second rule, the third rule, and then this one here is the fourth rule. Okay, so we've done multiplication, division, a power to a power, and then a number raised to the power of 0. So the next one then, or the fifth rule, so we're talking about this one here. So the fifth rule, so again, this shows up in your log tables like this. So let's think about what that actually means. So what it's basically saying is, let me just change the colors here. So it's basically saying that a to the power of minus q is equal to 1 over a to the power, a to the power of minus p is equal to 1 over a to the power of p. So as an example of that, so if I had something like this, so let's say 4 to the power of negative 2. So this rule here would state that this is equal to 1 over 4 to the power of 2. Okay, like that. Similarly, if I have, let's say, 5 to the power of negative 1, okay, that's just going to be equal to 1 over 5 to the power of 1. Now, you don't need to put into the power of 1, you can just leave it as 1 over 5. And if I had something like this, so let's say I have 4 to the power of negative 5, that's going to be equal to 1 over 4 to the power of 5. So it looks something like that. So that's that rule there. Okay, so that's the fifth rule when we're dealing with negative indices. So sometimes when you're doing questions, it might give you an equation that looks something like that, and then in order to make it easy, we can convert it back to something like that. So again, remember these rules go both ways as well. So 1 over 4 to the power of 5 can be written as 4 to the power of negative 5. Okay, so that's the negative indices rules, and that's the fifth rule. So the next ones then that we will look at are these two here. Okay, so we've products to a power, or quotients to a power. So if we have a look at these two, so I'll just put this in here. So we'll call this 6. So let's look at what this rule tells us. So if we have something like this, so imagine we have, so I look at this first one. So this first one here. So if I have something like this, so I have, and let me just change the color here. So imagine I have something like, so 2 multiplied by 5, okay, to the power of 3. So see the way these are written beside each other, a to the power of, so over here on this side, so a to the power of b, that means a multiplied by b. So that's the same as writing it like this, so 2 multiplied by 5 to the power of 3. So basically what you do with that is you take each of the numbers that are inside the bracket and you raise them to the power of 3, and you're multiplying them by each other as well. So that, what would that look like? It would look something like this. So it's going to be 2 to the power of 3 multiplied by 5 to the power of 3. So that's what it looks like there. So that's basically, so 2 multiplied by 5 to the power of 3, that means you raise each of the numbers inside the bracket to the power of 3, just like this. Okay, and that's what that rule means here. That's what it looks like, or that's what this stands for here. Now if we look at this one here, so again, similarly, and if I just do this in a slightly different color as well, just so we can distinguish them from each other. So this one down here, so if I have something like this, so let's say I have 2 to the power of 2 over 5, okay, and then that's all raised to the power of 3. So again, what does that mean? What does this look like? It's going to be equal to 2 to the power of 3 divided by 5 to the power of 3. So it looks like that. And that's what this rule here is telling you. Okay, so that's the product to a power, or quotient to a power rule. And that's these two guys here. So the last one then are these two guys here. So just highlight these here. So this one and this one. And these are basically when you're dealing, or you're working with like a fraction. So let me just group these together. So we'll call this 7. So basically, what does this mean? So if we take the first one, so a to the power of 1 over q is equal to the cubed root of a. So if we take something like, let's say, as an example of that, so if we had something like 4 to the power of 1 over 2, that's just going to be equal to the square root or the second root of 4. Okay, or the square root of 4, which is just equal to 2. Okay, so 2 multiplied by 2. If I had something like this, so you had, let's say, 8 to the power of 1 over 3, that's just going to be equal to the third root. So the third root of 8. Okay, so it looks something like that, which is just going to be equal to 2. So 2 by 2 by 2 is equal to 4. So that's this first rule here. Okay, so a to the power of 1 over p. So for example, this would be the a, and then this would be the p. It's just going to be equal to the number that's on the bottom. So the indice is in a fraction form. So the number that's on the bottom of the indice of the fraction, so it's going to be equal to that root of the base number. Okay, so it looks something like that. So that's that first one. The next one then is this guy here. Okay, and it looks a little bit complicated, but it's not. Okay, so it's this one here. So basically, if you had something like, let's say if we had something like, let me see, let's try green. So if we had something like this, so imagine I have 4 to the power of 2 over 3. So it's going to be equal to, and if we have a look at this here, so this piece down here, if we have a look at this, so what's that going to look like? So this here, so it's basically going to be, it's going to be 4 to, okay, so it's going to be the fourth root of 4, oh no, sorry, the third root, should I say, so 3, and then this whole thing is going to be raised to the power of the top number, which is 2, okay? So you're taking this base number and you're getting the third root here, so it's the third root of 4, all raised to the power of 2. Okay, so that's what it looks like. So let's look at another example. So if we something like this, so let's say 8 to the power of 3 over 2, that's going to be equal to the second root, or the square root of 2, the square root of 8, and then it's all raised to the power of 3. Okay, so that's this seventh, if you like, seventh rule here. And again, you don't need to memorize these, and they're all in your log tables, but you do need to know how to use them and how to recognize what you're doing. So the next thing then that we want to look at then are equations that have indices. So this is kind of the next thing that you're going to be asked to do. So what does that look like? So it might look like something like this. So imagine I have 3 to the power of x minus 1, and that's equal to 81. Okay, so in order to be able to work with these, what you have to do is you have to change, let's say, the number here on this side so that it's arranged in this format here. In other words, it has a base of 3. So if we take 81, so what's another way we can write 81? Well, 81 can be written like this. So 81, if we were to write it in a form that has 3 as its base number, it's going to be 3 to the power of 4. So for example, 3 to the power of 4 is equal to 81. So that would be equal to 3 multiplied by 3 multiplied by 3 multiplied by 3, which is equal to 81. Okay, so we can take this here and we can write this side as a power of 3. So we can write it like this. So 3 to the power of x minus 1 is equal to 3 to the power of 4. Okay, so it's 3 to the power of 4. And basically what we're trying to do in this equation is solve for x, find out the value of x. So once we've written it like this, we have it in this format here. What we can do is we can get rid of the base numbers and then we can just make the indices equal to each other. So this is going to be equal to, if we just focus then on these, because we can get rid of the base number. So it's going to be x minus 1 is equal to 4. So now what we can do is we can just use algebra and we can work out what x is. So x minus 1 is equal to 4. So therefore, if I add 1 on this side and add 1 on this side to get rid of the 1, so that's going to be equal to minus 1 plus 1 is 0. So it's going to be x is equal to 5. So in this question here, so 3 to the power of x minus 1 is equal to 81. You're trying to solve for x. X is going to be equal to 5. Okay, so that's the first one. So this is a very common type of question here. So again, you need to write them so that they have the same base. Once they have the same base, then you can get rid of the base number and you can just focus on the indices, make them equal to each other, and then solve for the unknown, which is x. So if we have a look at this question here, so we've 2 to the power of x is equal to the square root of 2 divided by 2, and we're trying to solve for x. So what we can do is we can look at this and so what we want to try and do is we want to try and make it so that this here is as a power of 2, and then we can make them equal to each other and solve for x. So what we can do is we can have a look at this and we can start to rearrange this. So if we take this top part here, so the square root of 2, so remember, this is the second root, so there's a 2 here, like so, but we don't need to write it in, so it's just implied that it's there. So what we can do is we can rearrange this top part, so we can, and we can make it equal to, using this rule here, so we can use the reverse of this rule, okay? So, sorry, this rule here, okay? So q to the power of a is equal to a to the power of 1 over q. So what does that mean? So we can take this and we can rearrange it. So it's in this form here, but we can change it over into this form here. So that's going to be equal to, so it's going to be equal to, so it's going to be equal to 2 to the power of a half. Okay, so we're taking this and we're rearranging it to look something like this. Okay, so 2 to the power of a half. And we can do that because we can use this rule here. And that's going to be over 2. Okay, so now see the way we now have, so, and this is going to be 2, remember this is going to be raised to the power of 1. So now see the way we've taken this whole thing here and we've changed it into this format here. So why have we changed it into this format here? So now we can use the second rule here, so division. So for example, see the way these are the same two base numbers. So now what we can do is we can use this second rule to simplify it even some more. So 2 to the power of a half divided by 2 to the power of 1 is just going to be equal to 2 to the power of a half minus 1. Okay, so it's going to be equal to 2 to the power of a half minus 1, which is going to be equal to 2 to the power of minus a half. Okay, and that's using this second rule here. So what we've done now is we've taken this whole thing here and we've changed it into this form here. So now it's the same, it has the same base number as this. So now what we can do is we can make these equal to each other. So it's going to be 2 to the power of x is equal to 2 to the power of, so 2 to the power of minus a half. And now, because we have these same base pairs, we can just forget the base number like we done with the last one, and we can make these equal to each other. So x then is equal to minus a half. So here's another example of that question. Another example of a question in an equation involving indices. So again, we're trying to solve for x in this one. So 4 to the power of x is equal to 1 over 32. So what we want to kind of change it is, we want to change this so that this is to a base 4. So we can look at this and we can start to manipulate it. So 1 over 32, so that's going to be equal to 4 to the power of x is equal to 1, sorry, is equal to, let me just work this out. So it's going to be equal to 32 to the power of minus 1. Okay, so it looks something like that. So again, where is this coming from? So it comes from this rule here, so rule 5. So if we have 1 over 32, so remember this is 1, so 1 over 32, and then if we reverse that, it's going to be equal to a to the power of minus 1 over p. Okay, so we're using this rule and we're reversing it back. So remember, this is 1 over 1 to the power of 1. Okay, so it looks something like that. So now what we want to do is we want to change this so that we have the same base numbers on either side. So one way we can do that is we can think about, so we could write this as 2 to the power of 2. Okay, so 4 can be written as 2 to the power of 2, and that's all raised to the power of x, like so. So what's another way that we could write 35 or 32 as a power of 2? So we can write it as, so it would be 2 to the power of 5, and then that would all be raised to the power of minus 1. Okay, so notice now what we've done is we've changed these so that they have the same base number. Now what we can do is, so this is a power raised to a power, and this is a power raised to a power. So what we can start to do is we can start to use this rule up here, so rule 3. So in rule 3, it just basically says that we just multiply these powers by each other. So it's going to be 2 to the power of 2x, like so. So it's just these two multiplied by each other is equal to 2 to the power of 5 to the power of minus 1. So it's just going to be 5 multiplied by minus 1. So it's going to be 2 to the power of minus 5. And now because we have them now as the same base, like so, we can just forget the base numbers and let the indexes be equal to each other. So it's going to be 2x is equal to minus 5. 2x is equal to minus 5. And then we can just get rid of the 2 in front of the x. So let's divide that by 2, divide that by 2, and then x is going to be equal to it's just going to be equal to minus 2.5. Okay, like so. Okay, so that's again another example of an equation that has an indice in it. So, okay, so that is indices, and we have looked at the rules of indices. So just as a kind of quick recap, so we're finished now. So what we done was we looked through each of the rules, and you need to know these rules of indices. So the rules, you don't need to memorize them, they're all contained within your logbook on page 21. So the first one is multiplication. So basically, when we have two powers and we're multiplying by each other and the base numbers are the same, we just add the indexes together. When we're dividing them and the base numbers are the same, we just subtract the indexes from each other. If we have a power to a power, we just multiply the indexes, the index on the inside of the bracket by the index on the outside of the bracket, like so. Anything raised to the power of 0, any number raised to the power of 0 is just equal to 1. So negative indices, we turn it into a fraction. So 4 to the power of negative 2 is equal to 1 over 4 to the power of 2. The product to a power, so again, if we have 2 multiplied by 5, for example, to the power of 3, that's just equal to this to the power of 3 multiplied by this to the power of 3. And the same when we're dividing as well. So each of the top and the bottom will get the power. And then with the fractions then as well. So we looked at these fraction examples. And then we have, equations that have indices in them then as well. We've looked at how to solve them. So basically what you want to do is get them so that they have the same base number. And then what you can do is you can get rid of the base number and you can make the top equal to, make the indices equal to each other, and then solve for the unknown quantity. So that's equations with indices. And again, you're using these rules here as well. So that is indices, and then that is the rules of indices.